Okay, now that we have our looking done and we have our inputs mapped, we can now start adding WSAD movement so that we can actually get to our sign and be able to interact with it. So we'll start by doing our move front back function in our player character class in the CPP. And we're using the player controller that comes with player character, so just to avoid any null reference crashes, we're going to check if that exists, just to make sure. And we're also going to check if the value is not 0, because if the value is not 0, we want to run the code. If the value is 0, this isn't actually being, because this is being polled even when you're not pressing it. So if the value is 0, don't run this code that we're about to run, because we can save on some processing time. So we're going to have to get the rotation using an F rotator of our actor, which we can just do get actor rotation. And if we're moving forward and backwards, we might be looking at the ground or into the air. So if we are moving on the ground, which would be a character movement function, is moving on ground. Or if we're falling, we want to just set that rotation's pitch to 0. We want to ignore any changes in pitch so that we don't move through the ground, or we're not able to move around when we're falling as well, because that wouldn't be very realistic. After that, we want to get our direction vector, F vector, sorry, direction, and then we'll pass that into a rotation matrix struct. We'll pass in the rotation rotator, and we'll get the scaled axis from that, which basically means we're going to get the local x, and we're going to get it scaled based on what was specified in the rotation matrix we created. So in execution order, it's going to create a rotation matrix with rotation, and then it's going to call this function on that in one line. So now we have the direction that we want to move in based on our rotation on our x-axis, which in Unreal is forward. In some engines it is Z. Unity comes to mind. And then we just want to add that movement in. We literally just want to add movement input, and we want to send it in the direction that we're going and how much we want to go in that direction. So if we were using a joystick, it would be that value would be scaled, or our movement in that direction would be scaled by how much you are pushing that joystick in a certain direction. And our move left right function is a little bit easier, because we don't have to count for rotation and stuff. We're just moving along one axis. So we just want to check again if the value is 0, because if it's not, we want to do these operations. If it is 0, we want to make sure that we don't do these extra operations. So we'll make our rotation and we'll get actor rotation. Actually, to be safe, we're never going to want to change these things. Oh yeah, we do. Ha! Just tells you how much I pay attention to my own code. However, we can make this constant. We can make the direction constant because we are not changing it. We don't want it to be changed. And if we ever do, we can remove that keyword. It just lets everyone know that, you know, we aren't planning on changing this. Don't try to change it because that's going to break a bunch of stuff. And then we do the exact same thing with this. We pass in the rotation that we got. We get the scaled axis. But this time we use axis Y, which would be our left and right local. And then we just add that movement based on our direction and our value. So now we can actually come in here, close our editor, and build ourselves back up. And when this loads up, we should be able to move forward, backwards, left, and right, based on where we are looking. There we go. Now we can strafe, we can move forward, and we can both strafe and move forward. So now we can actually get up to our sign. We can look at our sign like this, and we can't jump. We have not built the jump functionality, and we're not going to do that just yet. But what we are going to do is we're going to build a function for our player character, and we're going to call it trace from self. And basically what we're doing is we're just going to modularize this functionality so that we can just call this and make the code where we use this, reuse this code a lot cleaner. So we'll do bool trace from self, which will return a bool if it's a successful hit. If otherwise, it will return false, and we'll take an f hit result, and we'll use the reference operator to make sure that it cannot be null. We have to have a f hit result. We'll make a how far do we want to trace? How far do we want to maybe go a meter in front of us, or do we want to check, you know, 120 meters in front of us? And we need to take a collision channel. What do we want to collide with? Do we want to ignore anything? Do we want to only collide with certain things based on whatever you might have specified? Now that we have that, we can create our implementation for it. And what this is going to do is it's going to send out a array, basically, which the Unreal Engine calls a trace. And we're going to see if that intersects with anything. If it does intersect with anything, we'll fill the hit result with the information of that collision, and we will work with that. What are you telling me? Did I forget something? It's hard to tell whether I forgot something or I didn't forget something, because sometimes this stuff just tells me there's an error, but there's actually no error. More so with Unreal than anything else. But we're going to be using the controller, so we're going to check if that exists, just to make sure. And we're going to take the camera location, and we're going to take a camera rotation, and we're going to fill these, we're going to fill these using the controller's function, get player viewpoint. and we'll pass in the location, which will be filled, and we'll pass in the rotation, which will be filled by this function. So we're going to come out, we're going to have the camera location, and we're going to have the camera rotation, and then we can actually cast a ray directly in front of us. Also, to use the built-in functionality to cast a trace or cast a ray, we need a start location. We're going to need a direction, and we're going to need how long is that trace from the location that you started to where it no longer casts anymore. So only things within that certain distance will be collided with. So we'll take an F vector, we'll make it constant because we don't want to change this stuff, and that's where we want to start the trace. And that we'll do from ourselves, which is basically the camera location, because that is where that's the viewpoint that we're in. If we were in a third person, we might want to check it from maybe the center of the torso and forward, or from the head of the model and forward, or the gun, whatever your case may be. And we'll take a constant vector and we'll call that a shoot direction, and we'll do that camera rotation dot vector. I did get some of this code from a tutorial on the internet just to see how rays were handled in Unreal Engine, but I've modified it just ever so slightly to fit this function so that I can use it in certain ways. I will post that tutorial in the comment or in the description of this video, and you guys can go see their version of it as well. So we'll take the end trace, which is just the start trace, your start location, and you want to add the shoot direction plus the length. So we have the shoot direction, so we'll add that to the vector, and then we'll multiply that by the trace distance. So how far do we want to cast this trace? I called it tracked distance. We want to change that in both. There we go. Now that we have the direction vectors, or the direction information for our ray, we'll want to set up some collision query parameters. Collision query params, and I don't like typing things like params, so I'm just going to do params. It's easier for me to type that, and we're going to just create it quickly so that it's not null with an F name. Let's give it a name of let's say trace from self. We'll want to say yes, we want to trace complex, and ignore ourselves, because we don't want to collide with ourselves. Otherwise, every time we cast this, it's going to return, and it's going to be us that the information describes. So we'll set a bool here, and we'll call it hit returned, and that will help us determine if we've actually hit anything. We're going to need the world, so we'll have a uworld pointer, and we'll get the world, and we'll check if that actually works so that we don't crash, and then we'll set bHitReturned to the return value of the world function line trace single. We'll pass in outResult, which it will fill for us, and it will come out of this function filled with the information. Start trace, end trace, the collision channel in which we wish to ignore or block collisions, and the trace parameters. We'll pass these in because we'd like a name for this trace. We would also like maybe to specify some other things, such as whether you're tracing in the async scene, etc., which you can check by checking the API for collision query params. And then once we come out of here, we'll return bHitReturned, And if we end up coming to here, we could also return bhit return. We could maybe declare that outside of here, but instead, for both verbosity and just it makes sense, we'll return false if we get to this area. So if we don't have a controller, nothing was hit because we weren't able to cast out our trace. So now that we have that, we can now use that in our use function. The use function is what we're going to, when we hit the E button, we're going to cast out array, and we're going to check whether that has collided with our sign. So what we're going to need to know is our sign is called sign mesh, but we're not going to use sign mesh. We're going to create a blueprint for the sign. We're going to use a custom class which we named sign. So there it is. Click sign, select, that'll be our base class, and we'll do BP sign mesh. So we know it's a blueprint of our sign mesh. And then in here we can set, we'll set a static mesh. Oops. Did not mean to do that. As the parent, we'll set that. Oops. There we go. Oops. Sorry, I'm falling over myself here. We'll just call that the static mesh. And we'll set the, maybe need to make this bigger. There we go. We'll go down here and you'll go to sign mesh here, and in our component view we now have the static mesh as our sign. We can press Alt to tumble around this. We can see that is in fact our sign that we created earlier. So we'll save that out, we'll compile that, and what we'll want to do is, you probably typed better than I did, change that. Oh, that didn't work. That's weird. Well, we'll leave that for now. Could just be a bug in the editor, or it could have been something I did or didn't do. Completely possible too. So when we use something, we're definitely going to want to send out, at least in our context, a hit result. So we're going to create this immediately, call it hit result, and we're going to give it a force init enumeration to force initialize it, because we need this to be initialized for our lovely trace function, which we will use the line underneath, the btrace success equals trace from self. We'll pass in hit result so that it gets filled. We'll only want to send out maybe, let's say, 1.5 meters, so 150 units forward, e-collision channel ECC engine channel trace 1 for now. And then we can see, have we had a successful trace? If so, we want to run some functionality, otherwise just break, get out of this function, and we'll come in and check it again the next time we press use. So what we're going to want to do is we're going to take the actor that we collided with, and we'll get the actor from the hit result. We'll check to see if that actually exists, to make sure that nothing breaks, and then we'll try and cast it into a sign. And for this, we're going to need to include sign.h so that we know about sign, and then we'll do assign pointer sign actor equals cast, and we want to cast into cast into a sign hit actor. If this succeeds and sign actor is not actually null, I can't tell if that's telling me an error or not, it's not, then we will work with that at that point. So what we're going to want to do is we'd want to take the message from the sign, and then we're going to take that message and display it as a debug message for now. And that will be it for this tutorial. We will start with this next, but we will have to have a message to actually extract from the sign at this point. So we'll give the message to the sign, we'll get a way to take that message from the sign in code, and we'll display it on the screen. So we'll see you then.